these are the extra multiple choice questions from the MAT from November 2023. Let's get straight into it. So we have a function that has an inflection point. So it's zero derivative, but not a maximum minimum. So that means it has an inflection point. Which of these also has an inflection point? Well, we need to use, well, we don't need to, but we should be using the example they've given us, right? This is a function with an inflection point. It looks like this. If we could just move this around left and right, up and down, we would create functions that are different to this that also just have an inflection point. And maybe one of them is this here. So I notice all of these minus 3x squareds. So, okay, well, if I just take one away from the inside of this to make this, that's going to give me, by binomial expansion, a minus 3x squared, right? Because of the 3 that comes out from the front there. So, okay, well, that's going to be fantastic. Now, when I expand that out, though, it doesn't actually give me all of these. It very close gives me this one, except there's a minus 1 here. So, okay, let's just add 1 to it. So this means I'm going to shift it 1 to the right and move it up 1. It's still going to be inflecting, right, because it's just this graph transformed. But when we expand this out, the 1s will cancel, and we're end up with this graph here. So therefore, this is the one that does it. Good. For B, then, let's just go through them one by one. So root, a 10th root is the power 1 over 10. We can multiply those things out, of course, and then log space 10 of 10 is 1. Once we bring that to the front, and we can just say this is 11 tenths or 1.1. Now, pi is like over 3. So this is definitely bigger than 1.5. So that goes away immediately because it's bigger than 1.1 by quite a long way. We can, for this here, we can just compare 11 tenths to 11 ninths. Of course, if you have a bigger denominator, that makes the fraction smaller. So we can cross this one out as well. Here we can maybe take, to compare a root, you could do this by a bit of estimation, but to compare a root with another number, if they're both positive, which they definitely are, we can safely just square both of them and then just compare the squares, and whichever has the larger square was the larger original number if they're both positive, which they are. Of course, this is way less than 150 over 100, which is 3 over 2. So therefore, this is the bigger one here. And sorry, this is the smaller one. What am I talking about? This is way bigger, 1.5, way bigger than 1.21. So therefore, this is the bigger one. So this is the smaller one still. So we'll cross that out. And now this is obviously suspiciously close to cos of 45. Now, if we look at the cos graph, cos is decreasing between 0 and 90. So therefore, this graph is a bit, or this number here is a bit bigger than this number because you're slightly further left on this graph. So okay, this is a bit bigger than this, but this here is just root 3 over root 2 because cos 45 is 1 over root 2. And that's the same number we saw here. This is a little bit, the number we actually want to look at is a bit bigger than this number. We've already discounted this number as being too big in the first place. So this number, which is a tiny bit bigger, is going to be too big as well. So therefore, A is the answer. This question's just kind of fiddly. You just need to say, okay, well, let's sum all the cubes up to 19 just by putting 19 to this formula, and we get this. And I'm just not going to bother calculating that for a bit. I'm just going to hope it factorizes nicely at the end. Now, I need to get rid of all the even cubes. So to do that, I'm going to replace k with 2k and just sum up to 9. Right, so when we do this, we're going to put in k as 1, we get 2 cubes, put in k as 2, we get 4 cubes, put in k as 3, we get 6 cubes, and then all the way up to 9 means 18 cubes. And now, of course, I can just expand that out and then move the 8 to the front. And now I can just use the formula again here by putting in 9. And we get this, the 8 cancels a little bit, you get this. And yeah, because, 2 times 100, yeah, sure. And now we just need to do this minus this. I hoped that I could get away with not doing any maths, but in the end I did. We can see that we're going to end up with a 900 at the end just by looking at the hundreds digits. So therefore, the answer is this here without any much further efforts. Okay, so all evens square to multiples of 4, all odds square to 1 more than a multiple of 4. So now we just need to look at this number here. Clearly 4440 is a multiple of 4. So therefore, this is 2 above a multiple of 4. So if we're adding two things to get a remainder 2, we either need remainder 1 plus remainder 1, or remainder 0 plus remainder 2, or remainder 2 plus remainder 0. I think that's basically all we can do. Now, to do that, I guess we could have remainder 3 plus remainder 3. Oh, I didn't think of that. Okay, I didn't think of that when I was typing this up, but I've just thought about it, and I'll cover that case as well. Now, okay, remainder 1 plus remainder 1. I think I actually started with the zeros. We can't have as remainder 0, because if this was remainder 0, that would be even, fine, that's okay. But for this to be remainder 0, you would, sorry, for this then to be remainder 2, you would need any of this to form a remainder. I mean, the best you can do is either y remainder 0, in which case the whole thing is remainder 0, or y is squared as remainder 1, if it's odd. in which case when you times by 3, you get a remainder 3, and you do 0 plus 3, and that's not a remainder 2. So that goes away, and this goes away for exactly the same reason. And then we get to this, but of course, okay, so you can have x squared be a remainder 1 if x is odd. But then if y is even, you get remainder 0, as discussed. If y is odd, you get remainder 1, but times by 3, and you get remainder 3. So that doesn't work either. Now the case of remainder 3 plus remainder 3, sorry, is that the last case? Yeah, it is, right? Remainder 3 plus remainder 3 would give you remainder 6, which is remainder 2. But of course, x squared can't be remainder 3 by this. So that goes away as well. So there are no ways of doing this. And I think at least out loud, I saved myself there. Okay, so d is just the amount of digits the number has. So clearly, s of 1 is going to be 20 to the power minus 1, because 1 has 1 digit. But so is s of 2, because 2 has 1 digit. And so is s of 3, all the way up to s of 9. Now, s of 10 is going to be 20 to the minus 2, because 10 has 2 digits. And likewise, all the way up to s of 99. S of 100 is 20 to the minus 3, all the way up to s of 999, of course. And now we're just adding these all up. So this is just s1 plus s2 plus s3, all the way up and so on to infinity. So, okay, we're going to have 9 lots of 20 to the minus 1, because all of the first s's give us 20 to the minus 1. So that's 9 lots of them from 1 to 9. 9 lots of 20 to the minus 1. We have 90 lots of 20 to the minus 2. Because, 99 minus 10 is 89. But of course, you're essentially starting at 0 here. So it's 0, 1, 2, 3, 4, 4, up to 99 or 89, I guess. And you have that extra 0 there. It gives you an extra 1 when you count those along. So that gives you 90 of them. And then there's likewise, for the same reason, going to be 900 of these 3-digit ones. So that makes that there. And now we can just factorize out a 9 to the 20 to the minus 1. And that's behind, obviously, 1 here. A 10 and then a 20 left over on the bottom there, and then 100 and a 20 left over, 2 20s left on the bottom there. This, of course, is just 9 over 20. This is a geometric series with starting number 1 and ratio a half, just because you times by 10 over 20 every time, which you can simplify down to a half. 1 over 1 minus r, or a over 1 minus r, is just going to be this. So that whole thing is 2. This is 9 over 20. The 2 cancels to make it 9 over 10. And that would be our answer. For f, this is one of those questions where you just need to read the definition of this thing that you've never seen before and not lose your head and just do it. So, okay, this is the function that they've given us. So if we replace CD with just AB, we're going to replace all of the C's and D's here with A's and B's respectively. So if we do that, this will change to an A, this will change to a B, that will change to a B, that will change to an A, which makes AB plus AB be 2AB, and that will change to a B to make 2B squared. And all you need, apparently, is for this top row to be 2 and the bottom row to be 0. We can divide everything here by 2, and then if you factorize this, you get this. So either B must be 0 or A must be minus B. If B is 0, you get A squared is 2, so A is plus or minus root 2. But you're only allowed to put integers into this, so that can't happen. If A is minus B, then from here we can just say that, or a squared is just minus b, or squared is just b squared, so that makes 2b squared equal 2. So b squared is 1, so therefore b is plus or minus 1, which makes a also plus or minus 1. Technically minus plus 1, it's the other way around. But in either case, there are 2 solutions, minus 1, 1, or plus 1, minus 1, I guess. So 2 solutions there. For G, this is one of those ones where you could do some proper maths on this, but if you're given multiple choices like this, we could just find counterexamples to get rid of all the cases. So let's just try and put in some numbers. So if you do 1, 1, you get a half into 1 plus 1 into 1 plus 1 plus 1, which is 3 plus 1 is 4. Does that get rid of any of these? Well, it gets rid of this, right? Because 4 isn't a triangular number, because the triangular numbers go 1, 3, 6. So that it gets rid of D. We're not just making the triangular numbers, because here's one that's not a triangular number. Then I just tried some more things. 0, 1 gave me nothing because it got me a 2. Which doesn't discount any of these things, I don't think. So, okay. Sorry, does it discount? Sorry, except the triangular numbers, yeah. So then you try this, and I went for this because I was trying to add on an odd number, so y equals 1, in order to get an odd number at the end, which would mean that this wasn't the answer. And also, nor is this, because 7 happens to be an odd prime. So great, get rid of both of those things. So all I'm left with is all positive integers, or all positive integers that aren't triangular numbers. So the best thing to do would be to try and make a triangular number. The most obvious case would be 1. Yeah, because then that would discount all positive integers. If I could just make 1. So let's just set this equal to 1. and think, well, okay, if you take away y from both sides, now y has to be bigger than 0. X doesn't, which is why I was allowed to use this earlier, but y does. So this here is either 0 or a negative number. Now, it can't be a negative number because this is positive because of these conditions, or 0. No, definitely positive, and this is positive. So, okay, we couldn't have y be bigger than or equal to 1. If it was, sorry, bigger than 1. If it was 1, this would be 0. But likewise, this can't multiply to make 0. Even if y is 1, this is not multiplying to make 0. So therefore, there is just no way to make 1, I don't think. So we can't make all the positive integers, and the answer will be this here, although I haven't actually done any real maths to prove that. Okay, the first thing I did here was I just tried some kind of base case. So I just set m to be 0, and therefore I'm just looking for solutions of this equals 0. Now, if you've done roots of polynomial things in further maths, you'll know that the 4 roots of this multiply together to make 2 over 2, which is 1. So great, the product is 1, except it could be not enough information if for some other value of m, we didn't get that. Now, by the way, if you haven't done roots of polynomial things, you can just think about the factorization of this, which would necessarily be 2 into x minus x1 into x minus x2, and so on. And then, of course, when you multiply all of the constants out and times by 2, you must get 2, which means all the constants must multiply to make 1. That's kind of where this whole thing comes from. Anyway, if you say m isn't 0, well, okay, all you're doing is setting this equal to this. You take away mx from both sides and factorize it in there, and then you notice that the root algebra, where the 4 things multiply together to make this over this, doesn't change, and the answer is definitely 1 anyway. And likewise, this wouldn't be any different either, and so we're all good to go. I is definitely the most fiddly question on here. You think about drawing these, so obviously these are a bunch of parallel lines going upwards. I didn't draw them all to start with. And these are a bunch of parallel lines going this way instead, a little bit shallower, not that it really matters too much. What I decided to do was think about these intersections here, because somewhere 1 minus 10x is going to look a bit like this. But what I need to know if I'm counting the intersections, like this intersection here where they all meet at 1, only counts as one intersection, whereas like this counts as another, this counts as another. But if this line went through there, then that would only count as one more intersection again, right? So it's going to matter how many of these double intersections this blue line goes through in order to make this count. And we have to be very fiddly here. So what I decided to do was look for some of these intersections first. And what you notice, for example, if you set this line equal to this line, is that you get an intersection at minus 1/3, 7/3. You can check the algebra, the maths for me if you want to, but I'm pretty sure it's that. Then I looked for this one, which is the intersection between minus x plus 3 and 2x plus 4, and you end up with this. And it becomes pretty clear, because both of these numbers go up by 1, and the distance between these two stays the same, you're always going to be at minus 1/3 as the x-coordinate. And then you can just plug in to find the y-coordinate, and you'll see that there's a line of intersections going straight down here at minus 1/3, which is kind of useful to know. So what I did was I drew everything and said there's an intersection at y, x equals minus 1/3. There's another intersection, and you can do the same kind of maths to show that x equals minus 2/3, and then another one at x equals minus 1. So we have these kind of 3 lines of where these double intersections go through like this. And now again, I need to think about where this 1 minus 10x graph goes. I decided to find this coordinate here, which is kind of the most leftwards intersection we've got. That's the intersection between the top line here, 2x plus 9, and minus x plus 6, I guess. And that's there if you do the maths. Of course, we know it's x equals minus 1, so you can just put that into minus x plus 6, and you get 7, of course. Now, this line here, at x equals minus 1, goes through 11, so it's way higher than that. So, okay, it doesn't intersect this minus 1 line anywhere, but what about the minus 2/3 and the minus 1/3, right? Let's be a bit more careful. So what I decided to do was find where this graph is at minus 1/3, and it's at 13/3, if you just put in minus 1/3 into here. And likewise at minus 2/3, it's 23/3, and then of course, following the pattern, 33/3 for 11, which is what I already said. So okay, what I need to know is any of these double intersections, is there a double intersection at minus 2/3, 23/3? Is there one of those there? And what you can do is, and likewise at minus 1/3, does it go through 13/3? Do any of these doubles go through that exact number? Or does this line kind of pass through in the middle of one? You can actually just see a pattern from the first two that I got, 7/3 to 10/3. The next one is 13/3. So okay, that means that this blue line that I'm going to put in definitely goes through that one. It looks a lot like it's going to go through this one as well. And we can very quickly prove that by putting in minus 2/3 into the very top line, which does indeed give us 23/3 if you just do the maths, put minus 2/3 into the top line here. And therefore we can just count 1, 2, 3, 4, 5, 6, 7, because it's a double, 8, 9, 10, 11, 12, 13. We'll get B as 13. Very fiddly question, I thought. But yeah. Last question then. Immediately just put in 0, 0 and see what happens. If you do, you get 0 equals 0, so it definitely goes to the origin, so discount this graph. The difference between these four graphs is that these two have more roots than these two. So let's just try y equals 0. And we'll get all of this is 0 equals x squared into 1 minus x squared minus 0. And so we have roots at x equals 0 or x equals plus or minus 1. So we can discount these graphs as well. So we're down to these two. Now, there are lots of very complicated ways you could try and sort this out. But what you want to do is look back at this and just notice that the numbers and the powers are very suspicious. Because there's 4s, there's a couple of 4s, there's a 6 here. And then you've got these y squared x, and then y to the 4. If you expand this out, you'll end up with a y squared x squared. You'll also get, if you expand the y out, basically, if you expand it out and rearrange, you'll actually just end up with a perfect binomial on one side, just moving this thing and this thing over, which is difficult to spot, but if you've got enough time staring at it and just enough time to try stuff out, this is the kind of thing, just expanding and collecting, the kind of thing that at some point you should just get round to after trying a few other things that maybe didn't work so well. Anyway, this perfectly factorizes to y plus x to the power 4. And at this point, you can do some more complicated maths than I'm about to do. But what I just decided to do was say, well, okay, the roots I know are 0, minus 1, and 1. So if I just try x as 2, this graph says that the two y coordinates should be positive, and this one says that they should both be negative. So let's just put x equals 2 and find out. We get this. The fourth root of 4 is obviously much smaller than 2. So both of these numbers are negative, so therefore D is the correct answer. And those are all the questions done. Thank you so much for watching.